Hello everyone, I'm Professor Diwa and welcome to another math video. In this video, I'll be going over rational exponents. Our objectives are to understand the meaning of the rational exponent rules a to the 1 over n power, a to the m over n power, and a to the negative m over n power. Use rules of exponents to simplify expressions that contain rational exponents. Use rational exponents to simplify radical expressions. Alright, so let's get started. First, we're going to go over the definition of a rational exponent in the form a to the m over n power. If n and m is a positive integer greater than 1, with m over n in simplest form, then we have a to the m over n is equal to the nth root of a to the m, which is also equal to parentheses nth root of a raised to the m power, as long as the nth root of a is a real number. So according to our definition, there's two different ways we could rewrite a rational exponent. Starting with the rational exponent a to the m over n power, we could rewrite this as the nth root of a to the m power. So notice here that the denominator of our rational exponent n became the index of our radical. And then also the numerator of our rational exponent m became the new value of the exponent for the base a. Now the second way we could rewrite our rational exponent is taking the nth root of a, putting it inside of parentheses, and raising it to the m power. So notice here that the denominator of our rational exponent n is still the value of the index of the radical. However, the numerator of our rational exponent m is now the exponent on the entire radical. So in general, the denominator of our rational exponent n will always be the index of the radical. And the numerator of our rational exponent m can either be the exponent on the base a, or it could be the exponent of the entire radical. So in the next set of examples, I'm going to show you how we convert back and forth from a rational exponent into radical notation and vice versa. For example number 1, use radical notation to rewrite each expression. Simplify if possible. For part A, we have 9 to the 1/2 power. To convert this into radical notation, we start with the radical and 9 on the inside. The index of the radical will be the same value as the denominator of our rational exponent, so we have a value of 2 for the index. The exponent on the 9 will be the same value as the numerator of our rational exponent, which is 1. So we have the square root of 9 to the 1 power. However, in general, we don't write the value of the index if we're working with the square root, and we don't write the value of an exponent if it's just 1. So we just rewrite this as the square root of 9. Since we could take the square root of 9, we need to simplify this further. Our final answer is just 3. Moving on to part B, we have parentheses, negative 64, and everything is raised to the 1/3 power. Since the denominator of our rational exponent is 3, our index of the radical will also be 3. Since the numerator of our rational exponent is 1, we don't need to write the exponent of 1 on the negative 64. So rewriting this in radical notation, we get the cube root of negative 64. Because we could take the cube root of negative 64, we need to simplify this further. Our final answer is negative 4. Moving on to part C, we have negative 100 raised to the 1/2 power. Be really careful with this problem. The 1/2 power is only on the 100. We don't include the negative under the radical when we rewrite this in radical notation. The negative will be outside of the radical. So we would rewrite this as negative square root 100. Next, we could simplify. We just take the square root of 100, which is 10, and then we bring down the negative sign. So we have negative 10 for our final answer. For part D, we have a set of parentheses, 81x to the 8th power on the inside, and then the parentheses has the exponent of 1/4. Since the denominator of the rational exponent is 4, the index of our radical will also be 4. So we could rewrite this in radical notation as the 4th root of 81x to the 8th power. Next, we could simplify this. The 4th root of 81 is 3, and the 4th root of x to the 8th power is x squared. So our final answer is 3x squared. For part E, we have 5z to the 1/3 power. Because the 1/3 is only on the z, we don't include 5 under the radical. So we get 5 times the cube root of z. Next, we have a practice problem. Use radical notation to rewrite each expression. Simplify if possible. For part A, we have 25 to the 1/2 power. For part B, we have parentheses, negative 27, all raised to the 1/3 power. For part C, we have negative 64 to the 1/2 power. For part D, we have parentheses, negative 27y to the 6th power, and everything is raised to the 1/3 power. For part E, we have 7b to the 1/5 power. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the answers. Alright, so let's go ahead and get started with part A. We could rewrite 25 to the 1/2 power as square root of 25, and then we could take the square root of 25, which is just 5. For part B, we could rewrite this as the cube root of negative 27, and then the cube root of negative 27 is negative 3. For part C, we could rewrite this as negative square root of 64. The square root of 64 is 8, and then we bring down the negative, so we get negative 8. For part D, we could rewrite this as the cube root of negative 27 y to the 6th power. Simplifying this, the cube root of negative 27 is negative 3, and the cube root of y to the 6th power is y squared. So our final answer is negative 3y squared. For part E, we could rewrite this as 7 times the 5th root of b. For example number 2, use radical notation to rewrite each expression. Simplify if possible. For part A, we have 25 raised to the 3/2 power. Now there's two different ways we could rewrite this. We could rewrite this as the square root of 25 cubed, or we could rewrite this as parentheses, square root of 25 on the inside, and then the cube on the parentheses. You could see here that the square root of 25 cubed would be more difficult for you to do by hand. This problem is actually easier to simplify in the second format. We could take the square root of 25, which is 5, and then just cube the 5. Our final answer would just be 125. So we're going to rewrite the next set of problems in this format. For part B, we have 64 to the 2/3 power. We could rewrite this as parentheses, the cube root of 64 on the inside, and a square on the parentheses. The cube root of 64 is 4, and then we square the 4, which is 16. Moving on to part C, we have negative 9 raised to the 5/2 power. For this problem, be really careful when converting it into radical notation. The negative should be included on the outside of the parentheses, not on the inside. So we would rewrite this as negative, parentheses, square root 9, and an exponent of 5 on the parentheses. Next, we could simplify. We take the square root of 9, which is 3, so I have negative parentheses 3, and then an exponent of 5 on the parentheses. Next, we take 3 and raise it to the 5th power. This is 243, and then we bring down the negative. So our final answer is negative 243. Moving on to part D, we have parentheses, 1/9 on the inside, and then we have the exponent of 3/2 on the parentheses. Converting this into radical notation, we get parentheses, square root of 1/9, and then a cube on the parentheses. Next, we could simplify. We break apart the square root into two square roots, so I have parentheses, square root of 1 over square root of 9, and then a cube on the parentheses. Next, we take the square root of 1, which is 1, and the square root of 9, which is 3. We get parentheses, 1/3, and then a cube on the parentheses. Next, we take 1/3 and cube it. Our final answer is 1/27. For part E, we have parentheses, 4x minus 1 on the inside, and an exponent of 3/5 on the parentheses. We could rewrite this in two different ways. We could rewrite this as parentheses, the 5th root of 4x minus 1 on the inside, and a cube on the parentheses. or we could rewrite this as the fifth root of parentheses 4x minus 1, and then a cube on the parentheses. Next, we have a practice problem. Use radical notation to rewrite each expression. Simplify if possible. For part A, we have 16 raised to the 3 over 2 power. For part B, we have 27 raised to the 2/3 power. For part C, we have negative 16 raised to the 3 over 4 power. For part D, we have parentheses 1 over 4, and then we have an exponent of 3 over 2 on the parentheses. For part E, we have parentheses 2x plus 1, and an exponent of 2 over 7 on the parentheses. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's get started with part A. We could rewrite this in radical notation as parentheses, square root of 16, and then a cube on the parentheses. Taking the square root of 16, we get 4. 4 cubed is 64. For part B, we could rewrite this as parentheses, cube root of 27, and then a square on the parentheses. We could take the cube root of 27, which is 3. 3 squared is 9. For part C, we could rewrite this as negative, parentheses, fourth root of 16, and then a cube on the parentheses. Taking the fourth root of 16, we get 2. 2 cubed is 8, and then we bring down the negative. So the answer is negative 8. For part D, we could rewrite this as parentheses, square root of 1 over 4, and then a cube on the parentheses. The square root of 1 over 4 is 1/2, and then we take the cube of 1/2, which is 1 over 8. For part E, we could rewrite this as parentheses, seventh root of 2x plus 1, and a square on the parentheses, or we could rewrite it as the seventh root of parentheses, 2x plus 1, and a square on the parentheses. Next, we're going to go over the definition of a negative rational exponent in the form a to the negative m over n power. We have a to the negative m over n power is equal to 1 over a to the m over n power. We also have 1 over a to the negative m over n power is equal to a to the m over n power, as long as a to the m over n is a non-zero real number. According to this definition, we could convert a to the negative m over n power into a positive exponent by using the reciprocal and changing the exponent from negative to positive. So this would be 1 over a to the m over n. If we have 1 over a to the negative m over n, again we could use the reciprocal and change the exponent to be positive. So this would be a to the m over n. For example number 3, write using positive exponents and simplify. For part A, we have 36 to the negative 1/2 power. So to rewrite this using positive exponents, we use the reciprocal and we change the negative exponent to a positive one. So this would be 1 over 36 to the 1/2 power. Next, we can simplify by converting this into a radical. 36 to the 1/2 power would be the square root of 36. So I have 1 over square root of 36. Next, we take the square root of 36, which is 6. So our final answer is 1 over 6. Moving on to part B, we have 1 over 27 to the negative 2/3 power. To rewrite this using positive exponents, we just take the reciprocal and change the exponent from negative to positive. So we get 27 to the 2/3 power. Next, we rewrite this in radical notation. This would be parentheses, cube root of 27, and then a square on the parentheses. Next, we simplify. The cube root of 27 is 3, and then the square of 3 is 9. Moving on to part C, we have parentheses, 6a, and then we have negative 5 over 4 power on the parentheses. Next, we rewrite this with the positive exponent. This would be 1 over parentheses, 6a, and then an exponent of 5 over 4 on the parentheses. Next, we convert this to a radical. So our final answer would be 1 over parentheses, fourth root of 6a, and then an exponent of 5 on the parentheses, or we could rewrite this as 1 over the fourth root of parentheses 6a, and then an exponent of 5 on the parentheses. Next, we have a practice problem. Write using positive exponents and simplify. For part A, we have 81 to the negative 1/2 power. For part B, we have 1 over 8 to the negative 2/3 power. For part C, we have parentheses, 13x, and an exponent of negative 3 over 2 on the parentheses. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's go ahead and get started with part A. We could rewrite this using positive exponents as 1 over 81 to the 1/2 power. Next, we convert this into a radical. We get 1 over square root of 81, and now we simplify. Square root of 81 is 9, so our final result is 1 over 9. For part B, we could rewrite this as 8 to the 2/3 power. Next, we convert it into a radical. This would be parentheses, cube root of 8, and then a square on the parentheses. Taking the cube root of 8, we get 2, and then square the 2 to get 4. For part C, we could rewrite this as 1 over parentheses 13x, and then we have an exponent of 3 over 2 on the parentheses. Next, we rewrite this in radical notation. We have 1 over parentheses square root of 13x, and then a cube on the parentheses. Or we could rewrite this as 1 over square root parentheses 13x and a cube on the parentheses. Next, we have a summary of exponent rules. First, we have the product rule. If we have a to the m times a to the n, this is equal to a to the m plus n. So when we have the operation of multiplication between the bases of our exponents, we just take our base and then we add the exponents together. Next, we have the power rule. We have parentheses a to the m and then an exponent of n on the parentheses. This is equal to a to the m times n. So when you have an exponent raised to another exponent, you just multiply the two exponents together. Next, we have the power rules for products and quotients. We have parentheses ab and then the exponent of n on the parentheses. This is equal to a to the n times b to the n. We also have parentheses a over c and then an exponent of n on the parentheses. This is equal to a to the n over c to the n. Next, we have the quotient rule. We have a to the m power over a to the n power. This is equal to a to the m minus n. So whenever we're dividing the bases of exponents, we just take the base and subtract the exponents from one another. Next, we have the zero exponent rule. A to the 0 power is equal to 1. And then we also have the negative exponent rule. A to the negative n is equal to 1 over a to the n, and 1 over a to the negative n is equal to a to the n. Alright, so in the next set of examples, we're going to use our exponent rules to simplify. Next, we have example number 4, simplify. For part A, we have x to the 1/2 power times x to the 1/3 power. Because we're multiplying the bases, we add the exponents together. So we just take the base x, and then we add the exponents 1/2 plus 1/3. Adding two fractions together, we need to use the LCD, which is 6. So we can rewrite our exponents as 3 over 6 plus 2 over 6. Next, we add them together, which is 5 over 6. So our final answer is x to the 5 over 6 power. Moving on to part B, we have 7 to the 1/3 power divided by 7 to the 4/3 power. Because we're dividing the bases of the exponents, we just take the base 7 and then subtract the exponents. So I have 7 to the 1/3 minus 4/3 power. Subtracting the exponents from one another, we get 7 to the negative 3 over 3 power, which simplifies to 7 to the negative 1 power. Next, we use our negative exponent rule. This becomes 1 over 7. Moving on to part C, we have y to the negative 4 over 7 power times y to the 6 over 7 power. Since we're multiplying the bases of the exponent, we take the base y and add the exponents together. So I have y to the negative 4 over 7 plus 6 over 7 power. Combining the exponents together, we get 2 over 7. So our final answer is y to the 2 over 7 power. Moving on to part D, we have parentheses, and then 5 to the 3 over 8 power, and an exponent of 4 on the parentheses. Since we have an exponent raised to another exponent, we just multiply the exponents together. So I have 5 to the 3 over 8 times 4 power. Multiplying the exponents together, we get 12 over 8. So I have 5 to the 12 over 8 power. Next, we simplify by reducing the 12 over 8, which is 3 over 2. So our final answer is 5 to the 3 over 2 power. Next, we have a set of practice problems. Simplify. For part A, we have x to the 1/3 power times x to the 1/4 power. For part B, we have 9 to the 2/5 power divided by 9 to the 12 over 5 power. For part C, we have y to the negative 3 over 10 power times y to the 6 over 10 power. For part D, we have parentheses, 11 to the 2 over 9 power, and then a cube on the parentheses. Alright, so go ahead and pause the video, simplify these problems, and then check back with the video to see the answers. Alright, so let's get started with part A. For part A, we use the product rule, so we take our base x, and then we add the exponents 1/3 plus 1 over 4. So I have x to the 1/3 plus 1 over 4 power. Next, I converted the fractions to have a denominator of 12, so I have x to the 4 over 12 plus 3 over 12 power. Adding our exponents together, we get our final answer, which is x to the 7 over 12 power. Moving on to part B, we use the quotient rule to simplify. So we take the base 9, and then we subtract the exponents. So I have 9 to the 2/5 minus 12/5 power. Subtracting the exponents, we get 9 to the negative 10 over 5 power. Simplifying negative 10 over 5, we get 9 to the negative 2 power. Using our negative exponent rule, we could rewrite this as 1 over 9 squared. Next, we square the 9, we get our final answer, which is 1 over 81. For part C, we use the product rule. We take the base y, and then we add the exponents together. So we have y to the negative 3 over 10 plus 6 over 10 power. Adding the exponents together, we get our final answer, which is y to the 3 over 10 power. For part D, we have an exponent raised to another exponent, so we just multiply the exponents together. We have 11 to the 2 over 9 times 3 power. We multiply 2 over 9 times 3, we get 6 over 9, and then we reduce it. Our final answer will be 11 to the 2/3 power. For example number 5, simplify. We have parentheses, 2x to the 2/5 power, and then an exponent of 5 on the parentheses, all divided by x squared. To simplify this, we first distribute the exponent of 5 to all the terms inside of the parentheses. So we get 2 to the 5th power, x to the 10 over 5 power, divided by x squared. Next, we simplify the numerator. 2 to the 5th power is 32, x to the 10 over 5 power is x squared. So I have 32x squared divided by x squared. Next, we cancel out the x squareds. Our final answer is 32. Next, we have a practice problem. Simplify the expression, parentheses, 3x to the 2/3 power. We have a cube on the parentheses, and then everything's divided by x squared. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's go over the solutions. First, we distribute the exponent of 3 inside the parentheses. We get 3 cubed, x to the 6 over 3 power, divided by x squared. Next, we simplify the numerator. We get 3 cubed is 27, and then x to the 6 over 3 power is x squared. So we have 27x squared divided by x squared. Next, we cancel out the x squareds, and our final answer is 27. In example number 6, simplify using rational exponents and assume all variables are positive real numbers. For part A, we have the 8th root of x to the 4th power. First, we're going to rewrite this as a rational exponent. This would be x to the 4 over 8 power. Next, we reduce the exponent 4 over 8 to 1/2, so I have x to the 1/2 power. Finally, we convert this back into radical notation. This would be the square root of x. For part B, we have the 6th root of 25. To convert this into a rational exponent, we need to rewrite 25 as an exponent. This would be 5 squared. So I have the 6th root of 5 squared. Next, we convert this into a rational exponent. This would be 5 to the 2 over 6 power. Next, we could reduce the exponent of 2 over 6 to 1/3. So I have 5 to the 1/3 power. And then finally, we convert this back into a radical. So I have the cube root of 5. For part C, we have the 6th root of r squared s to the 4th power. First, we convert everything to rational exponents. We have r to the 2 over 6 power times s to the 4 over 6 power. Next, we reduce the fractions. 2 over 6 becomes 1/3, and 4 over 6 becomes 2/3. We get r to the 1/3 power times s to the 2/3 power. Finally, we convert this back into a radical. We get our final answer, which is the cube root of rs squared. Next, we have a practice problem. Simplify using rational exponents and assume all variables are positive real numbers. For part A, we have the 10th root of y to the 5th power. For part B, we have the 4th root of 9. For part C, we have the 9th root of a to the 6th power b cubed. Alright, so go ahead and pause the video, simplify each problem using rational exponents, and then check back with the video to see the answers. Alright, so let's go ahead and get started. So first we need to rewrite part A as a rational exponent. This would be y to the 5 over 10 power. Next, we reduce the exponent, 5 over 10. This would be 1/2. So we get y to the 1/2 power, and then we convert this back into a radical. Our final answer would be the square root of y. Moving on to part B, in order to convert this into a rational exponent, we need to change the 9 into an exponent. So we could rewrite 9 as 3 squared. We get the 4th root of 3 squared. Next, we convert this into a rational exponent. This would be 3 to the 2 over 4 power. Next, we reduce 2 over 4 to 1/2. We get 3 to the 1/2 power. Next, we convert it into a radical. We get our final answer, which is the square root of 3. For part C, we could rewrite this as a to the 6 over 9 power times b to the 3 over 9 power. Next, we reduce the exponents. 6 over 9 is 2/3. 3 over 9 is 1/3. So we get a to the 2/3 power, b to the 1/3 power. Rewriting our answer in radical notation, we get the cube root of a squared b. Next, we have example number 7. Simplify using rational exponents. For part A, we have the square root of x times the 4th root of x. First, we convert the radicals into rational exponents. So we have x to the 1/2 power times x to the 1/4 power. To simplify this, we use the product rule. So we get x to the 1/2 plus 1/4 power. To add the fractions together, we use the LCD of 4. So we get x to the 2 over 4 plus 1 over 4 power. After adding the exponents together, we get x to the 3/4 power. Next, we write our answer as a radical, so this would be the 4th root of x cubed. For part B, we have the square root of x divided by the cube root of x. To simplify this, we convert everything to rational exponents. We get x to the 1/2 power divided by x to the 1/3 power. Next, we use the quotient rule. We get x to the 1/2 minus 1/3 power. To subtract the fractions, we use the LCD of 6, so I rewrote the fractions as 3 over 6 minus 2 over 6. Subtracting the fractions, we get 1 over 6. So we have x to the 1/6 power. Next, we convert this back into a radical. We get our final answer, which is the 6th root of x. Next, we have a practice problem. Simplify using rational exponents. For part A, we have the square root of y times the cube root of y. For part B, we have the cube root of y divided by the 4th root of y. Okay, so go ahead and pause the video, simplify the problems using rational exponents, and then check back with the video to see the answers. Alright, so let's get started with part A. So first, we rewrite everything using rational exponents. We get x to the 1/2 power times x to the 1/3 power. Next, we use the product rule. We get x to the 1/2 plus 1/3 power. To add the fractions together, we use the LCD of 6. So I rewrote the fractions as 3/6 plus 2/6. Adding the exponents together, we get x to the 5/6 power. Next, we convert this into a radical. We have the 6th root of x to the 5th power. Moving on to part B, we convert everything into a rational exponent. We have y to the 1/3 power divided by y to the 1/4 power. Next, we use the quotient rule. We get y to the 1/3 minus 1/4 power. To subtract the fractions, I use the LCD of 12, so I rewrote the fractions as 4/12 minus 3/12. After subtracting the exponents, we get y to the 1/12 power. Turning this back into a radical, we get our final answer is the 12th root of y. Next, we have example number 8. Simplify using rational exponents. We have the cube root of 3 times the square root of 2. First, we rewrite everything with rational exponents. We have 3 to the 1/3 power times 2 to the 1/2 power. What we need to do next is rewrite the fractions using the LCD of 6. We get 3 to the 2/6 power times 2 to the 3/6 power. Next, we convert this to a radical. We get the 6th root of 3 squared times 2 cubed. From here, we simplify the terms inside the radical. 3 squared is 9 and 2 cubed is 8. So we have the 6th root of 9 times 8. Next, we multiply 9 times 8. This is 72. So our final answer is the 6th root of 72. Next, we have a practice problem. Simplify using rational exponents. We have the cube root of 2 times the square root of 5. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's go over the practice problem. First, we simplify by converting everything into rational exponents. We get 2 to the 1/3 power times 5 to the 1/2 power. Next, we need to rewrite the fractions using the LCD of 6. We get 2 to the 2/6 power times 5 to the 3/6 power. Next, we convert this into a radical. We get the 6th root of 2 squared times 5 cubed. Next, we simplify the inside of the radical. 2 squared is 4, 5 cubed is 125. So we get the 6th root of 4 times 125. Next, we multiply. 4 times 125 is 500. Our final answer is the 6th root of 500. Alright, so this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.